Folks, so it's Tuesday, and we are here at the second day of our conference at Illuminate AI. I really hope and wish that you got to learn new things from our sessions yesterday, and I really hope you do so in today's sessions as well. As I had mentioned earlier, this is a day long conference. We wrapped up the first day yesterday. Today is the second day, and we have 2 more days of the conference. So today we'll be having 2 sessions, and in between those 2 sessions, we are going to have the trivia round, which we had yesterday as well. So the trivia round will be like we'll be giving you a question, and the fastest person to answer for that question will be receiving the book of Between the Spreadsheets by Suzanne Walsh. So stay tuned in, like even during the break between the 2 sessions. That's when we'll be having the trivia. So make sure you're there to have your book. So let's start today's session with our first speaker, Nitin. It's wonderful having you, Nitin.
Yeah,
So
sure. How are you?
awesome, doing awesome. And thank you so much for agreeing to be a part of the conference. It's really like it's an honor to like have you here. So one of the interesting things I wanted to mention about Nitin is he's currently heading the cloud AI services of Google in India, and he has an experience of being the senior technical program manager of Google USA. So if you can briefly mention about your experience, Nitin, and then we can jump onto the session.
Good. Thank you so much, Ashwarya. Thank you so much for having me over here. So, hey everyone, I'm Nitin. Just like Ashwarya mentioned, I'm currently leading a cloud AI industry solution services team in India. I used to be a part of Google Cloud in US in the headquarters in Sunnyvale for last 4 years, where I was like a part as a senior technical program manager. My team responsible to build cloud AI based solutions and as well as architectures and to solve some really interesting and fun problems for our customers. I'm in this field of AI/ML for last 8.5, 9 years. I think all of my career used to be in AI/ML. I started my career as a software engineer. I didn't knew like at that point of a time that okay, hey, what is AI, what is ML? I started building some of the logistic regression models, some very basic optimization that transition into an SAS based models like linear regression and so on and so forth. And then finally it turned out to be into TensorFlow and moving forward to AIML. So that's about my quick background. Really excited for this session. I don't think that okay will be presenting a lot of technical topics, but I will be sharing some of the learnings that I got from my career, some of the mistakes that I made, and along with that, yes, if these are things that I would have known even while solving any problems, while doing any projects, while building any products, these things will be really helpful for me, and I will be missing a lot of pitfalls even beforehand.
Thanks a lot for that, Nitin. I've been following you on LinkedIn, and it's just awesome to read your content because it's really important that we share the nuances about the field, like in the sense that what can go wrong, what are the challenges, and how we can solve them. Because like building data science models or machine learning models is not as rosy or as perfect as one might think. So as you mentioned, like we have to think about how to scale this, right? Like between getting a model from a Jupyter notebook into production, there is a big bridge. So I'm really glad that you chose that topic, and we're going to be talking about that today. So without wasting much of the time, we can definitely jump into the talk.
Sounds good. Yeah, thank you so much, Ashwarya. I think let me quickly share my screen. I think, again, everyone, whatever the thoughts that I'm presenting in the next 30, 40 minutes, again, these are my personal thoughts. These are things, or these are the experiences that I got over a period of last 7, 8 years at least. You might have like some very different experience, but I'm not a big fan of starting with a small, starting with a Jupyter notebook and then talk about scaling things up later on. In my experience, what I have found that, okay, hey, if you do not start thinking at the scale from day zero, you are setting yourself for failure. So it means that okay, hey, what are the problems that you're solving? Think about that scale from day zero and day one, and then build a solution, build your strategy, and select the tools whatever you want to work on. So that's the overall theme for the next 20 30 minutes. If you have any questions in between, please feel free to like ping it over here. I would love to take those questions. In my experience, I found that okay, scaling is a very very big challenge. These are some of the reports that I mentioned from McKinsey, from Forbes, from HBR. Like less than 20% of the companies are actively or like successfully achieving scalable impact on data analytics, AI, and ML program. When we actually talk like these kind of customers by myself, and when I learned from over a period of time from various sources, I found that okay, hey, thinking about scaling, the thinking about that, how to scale things up, what are the potential challenges and pitfalls that will come throughout this journey, those are the basic concepts are missing. And we are missing those concepts, you're actually missing the whole idea behind building any ML model or building any of those systems. If you see some of these numbers, like almost 80% of the enterprise data is unstructured. 70% is almost like they are coming from text, written documents, some sort of an emails and comments, but only less than 1% of the unstructured data is being actually analyzed or used at all. So it means there is a lot of potential, lot many things, and those numbers that you can actually see that yes, it's not like that only 1% data is useful. You can actually make a comment and you can argue on that, but it means that we are not able to scale up our systems, we are not able to scale up our algorithms in such a way that we will be able to utilize a significant chunk of the data to make those decisions. The situations on the structured data side, a little bit like good. For an example, you can say almost 50% of the data is being used to make any decision, but still more than half of the data is still useless. You're not even using to make those kind of decisions or to even to make any business decisions. So it means an end-to-end thing. The majority of the things that will be coming out from this, first thing is that okay, directly jumping on using AI/ML for solving a problem, totally ignoring the data analytics. And the second thing is that scaling piece, the whole idea behind the scaling is missing. Along with that, what we identified that whenever we talk with a lot of teams, a lot of members, we identified that okay, hey, AI being just considered as a field for data scientists or ML engineers, it's actually a team sport. So it means if you want to actually make any project successful, you need a very tight collaboration between ML engineers, data engineers, software developers, data scientists, business leadership, and end user. The thing is that all of them and each of them must be actually targeting exactly the same vision, exactly the same target, and you should be actually targeting exactly the same output that you should be thinking out for. If we talk about that, okay, yes, how the journey has changed. In 70s, we came up with a decision tree. Engineers applied those kind of a decision tree with then machine outcomes, if and else statements, a lot of logical statements, and then you come up with those decisions. Over a period of a time, as we start getting some little bit more computing power, we said that okay, hey, the modeling and the simulation starts coming in. Around like 1989's neural network came into the picture as well. So they were like a small model started coming into the picture, small simulations, statistics were getting a lot of traction. And we, over a period of a time, when we actually moved into the deep learning side, we say that okay, hey, by 2010s, AWS came into the picture, a few other public cloud came into the picture. We got like a more computation power, and we started solving problems using deep neural network and so on and so forth. But in the next future, how it will look like, it will be an embedded intelligence. It means AI will be just acted as an enabler to make any decision. It will not be acting as some sort of, what I should say, beautiful or out of the box concept. But just like an analytics, it will be like that, okay, how to embed intelligence in my business decisions, in my products. So over a period of a time, if you see, the journey has been changed. So it means your thought process to actually start with a sample, working on a small data set, and then solving a problem, that needs to be changed. It means you have to thought about that, yes, if you will be like actually targeting gigs of terabytes of the data or petabytes of the data, how the system will scale. Your Jupyter notebooks, it can scale. Netflix is currently using Jupyter notebooks or those kind of like a notebook based structure in production. The idea is not about the tooling. The idea is about that, yes, what's the status, what's the status quo, what's kind of a processes that you're actually using to scale things up. Just to give you a very a brief background about the thought process across the various AI ML project spectrum. If you see that okay, majority of the AI projects will fall into these four spectrums. First thing is the commodity, where you're saying that okay, hey, you have a standalone APIs, you just need to make or call to that API. For an example, OCR extraction, speech to text generation, or text to speech, translation. So those kind of an APIs are already existing into the market. You can use Tesseract or something like that. So it means you just make a call, you are getting an output. it's a routine problem. You can actually scale things up and you can only focus on the execution. Very low risk, very low cost, and as well as very low ML skills are needed. So in this case, you can actually just work on the full data set, not on the sample. You can just check that, okay, yes, on these things, how these are actually making sense, whether these things are working, whether these APIs are working. But you are not going to solve a problem for a small data set. You need to think that, okay, whether this particular system will be actually used for an end-to-end product, for an end-to-end data or not. Second thing is the procedure. You say that, okay, no, I'm not happy with just directly making a call. I need to use some solutions like predefined solutions, document AI, predictive maintenance, or you can say call centers based solutions provided by a lot of public providers, public cloud providers. So it means you're actually integrating some complex programs into your systems. But again, in this case, you're not building something from scratch. Those kind of a systems or solutions already exist. You're using mature methodologies and systematic approach over a period of a time to actually gain some of those advantages, or to gain some of a performance with the help of these kind of solutions. So it means the overall professional skills, it will be like needed more than a commodity, but it will be like low cost, low risk, again low ML skills. Even in this case, you will not be working on a small samples. It means you need to work and you need to think about the scale. The third thing is about the gray hair. This is where majority of the ML project lies right now. When we say that of gray hair, it means you're actually building some custom models like AutoML based solutions, or if you're using BERT, or if you're using like an OpenGPT or something like that. So it means you have a track record of solving similar problems. You have the data, you have the right skill sets, ML skill sets. You can take risk. The cost will be high, but you're actually solving problems on the data set. You will be starting with a sample, but again, your thought process will be again targeting towards the scale, whether this particular solution, whether this particular algorithm will be able to solve your problem at a petabytes or zettabytes of data. Till these three kind of a buckets, majority of the, for example, more than 90 to 95%, in my experience, 99% of the projects will be done. And then come to the rocket science, where you're actually doing some sort of research. That particular problem has never been solved. It means you're actually solving a complex problem. Cost will be very, very high. Risk will be very, very high. And the very sophisticated ML skills will be needed. In this particular case, you will be actually using the scalability. You will say that, okay, the scalability will actually come last. At the moment, I will only be targeting the small sample. I will be targeting the scalability later on. But if you say that, okay, in the 99% of the use cases, you have to think about a scale, your process and your approaches will be definitely targeting the scale, not just a small sample, except the rocket science that's primarily on the research. Any thoughts or any comments that Ashwarya, if you have any?
I think we are good right now. We can come back to the question now in the next few minutes.
Okay, sounds good. Cool.
Awesome.
So if we talk about like a typical magic pyramid, we always talk about the top of this pyramid. But if you see that, okay, yes, what's the baseline? What are the benchmarks we're targeting about? They're saying the IT infrastructure and application data management. On the top of it, we need a data mart, data lake, and data warehouse. And on top of it, there will be some rapid prototyping that we should be actually targeting, the reproducible experiments and prototyping. On top of it, there will be analytics, and finally, it will be an ML and ML ops. If you see that, okay, hey, if you're actually targeting the whole magical pyramid, this AI analytics is actually focused on the strong data foundations and strong infra foundations. Without those kind of skill sets, without those kinds of know-how, you will never be able to scale things up. You will never be able to think about that, yes, how to actually build a train a model or manage a model at scale. If we quickly think about that, okay, yes, how the AI lifecycle looks like. If we talk about that, okay, what are the challenges that you will be getting at scale? This is a typical AI ML lifecycle. You're starting with data ingestion, moving on analysis, transforming the data, training the models, tracking those models, evaluating it, and final deploying. This is like a very, what I should say, an old school or at a school level AI lifecycle, that how to build those models. But if you're talking about that, okay, what are the challenges that you will be actually getting if you will be solving a problem at the scale? If you are saying that, okay, hey, I will be solving a problem at the scale in the managed data set, if you are actually using a data ingestion, a lot of the data will be on the silos. They are actually using various formats. They will be using various protocols. If you are using healthcare, it means somebody is using HLV7, somebody is using Fire. If you are using, like if you are in the financial services, somebody are using JSON, somebody are using XML. So it means various formats, various protocols that creates a reliability issues and as well as redundancy issues. Along with that, when you actually start working at a scale, Simpson's paradox that was not very, very prominent and not very visible in a small sample of a data, it start coming up very, very soon. In a very layman term, Simpson's paradox means if you are actually getting a trend and the overall data set, you think that okay, that's a trend. But when you actually divided that particular data into multiple buckets, the trend changes. It becomes, or it automatically reverses. That's like a Simpson's paradox. And along with that, there's a different transformations will be needed. In a typical experiments and a typical competition, you will say that, okay, hey, my data is coming from one source, very similar kind of a data dictionary. This is my data transformation, data preparation pipeline. I will train a model on. But now you need to create a different data transformation for each and every different use cases, each and every different data point, each and every data warehouse or data mart. So it means the kind of a work that you have done for data pre-processing that will becomes almost 10x or 20x what you have already done. So it means building that sort of a robust ETL pipelines, data pre-processing pipeline, that's going to be part of your model development itself. That will actually scale up things very, very fast. And if, for an example, if you're using Jupyter notebooks with hard-coded variables, those things will not scale up. It means you will be actually just getting a lot of technical debt. It becomes almost impossible to manage, and your pipeline will not work. And overall, like your end experiment will fail. The second point, we talk about the training. For an example, if you're saying that, okay, I need to train a model on, that will again depend upon what kind of a training mechanism that you will be selecting, whether you will be running a parallel experiments. In these kind of like solving problem at a scale, you do not need machine learning model first. You need a very basic and raw pipeline first, so that you can actually run those experimentation, multiple experimentation in parallel at scale, and then compare the performance. Because for an example, if a model is taking 8 to 10 days to get it trained, you are not going to wait for 8 to 10 days just to wait for the models, just to wait for the results to come in. So it means you need to run those multiple experimentation. You need a very basic pipeline, even at early stage, even before you have an ML model. The next point is about the model evaluation. It's not just going to be precision and recall. It's going to be latency and throughput. And that's going to be even more important than precision and recall. I can share an example. You're working with a bank and they need a real-time experimentation, like real-time results within 3 to 5 seconds. If you're not providing that sort of a throughput and a latency, any precision and recall, it is of no use for them. So it means if you cannot provide that, yes, whether this particular transaction is it's like a money laundering or very spurious transaction, and that transaction has done, and you're getting that response after 10 minutes, even if it's 100% accurate, it is of no use. So it means just like a precision recall curve, F1 score, AUC, those things become little bit like taking a backseat, and a lot of like infrastructure basic things like latency and throughput, they will start taking the front seat when you're actually solving these kind of a problems. Along with that, what kind of a model architecture that you will be using, what kind of scaling mechanism that you will be using, what kind of an inference pipeline that you will be using, that will automatically change based on the synchronous versus asynchronous mode. Along with that, based on these kind of requirements, your model size will become another thing that will directly impact your model architecture. How many layers of the neurons that you will be taking, what kind of a model architecture, whether you can take like whether you can build a ResNet, wide ResNet, ExaNet, or a squeeze net, or a capsule net, what kind of a network that you should be building to actually adhere to these kind of requirements. And finally, and the most important point, it's about endpoint and batch predictions. Deployment always comes up with its complexities. And whenever you say, hey, I need to deploy a model, a lot like the complexity will go just by 100x. Regional deployments, load balancers. For example, if I am in India, all the financial services team only need the deployment in India because data cannot go outside, right, or to the overseas. If you are in the EMEA, as per the GDPR guidance, any PI or PHI data cannot go overseas. So it means those kind of a local deployments and load balancers will be needed, and your model should be able to scale up and scale down based on those requirements. You can say that, okay, hey, a lot of these requirements and a lot of these requests and features will be automatically handled by the infrastructure team. But the thing is that those infrastructure will directly impact your model architecture, your process, your approaches. So you cannot be obscured from all of those requirements. You have to consider that, okay, hey, those things will be directly impacting to you. Till this point, we discussed about like a lot of basic and theoretical knowledge. Next few slides, let me share you some of the examples where we actually build some things. So this is like one of the example for the predictive maintenance. We are actually solving a business problem for like in the manufacturing. So it means around like 2 to 3% of the devices they failed every year. But any failure into the operations is very critical for these kind of organizations. any failures that needs to be predicted at least 60 to 90 minutes ahead of the time, so that we are actually providing uh, enough time to take any action for either to replace that particular thing or repair that particular machine or particular sensor. So that's a business problem that we're actually solving. Solution, it was like a very direct AI/ML based solutions. For an example, stream processing, getting a Kafka based systems like a stream processing data ingestion. After that, high fidelity data warehouse, we are storing the data after transforming and transformation. Multiple models were trained, like multiple various architecture, you can say PCA, LSTM, and encoder, autoencoder based, those kind of models. But the latency that we have to keep into the mind that yes, all the inferences we need within 60 to 90 minutes before the failure. It means we need at least almost real time predictions. What we have identified that these kind of an anomalies into the data only happened around 70 to 80 minutes before the actual failures. So it means ideally we only have 7 to 8 minutes to predict and as well as process and transmit those kind of details to the right people to take any actions. If you say that okay, yes, if I'm solving this problem at a smaller level, I can take a sample, process it, but these problems will actually magnified and they will be actually getting multiplied when you are solving that problem at scale. Some of the challenges that we got like 100 plus million devices that we were actually processing and streaming, it means you need that sort of a high throughput, high throttle pipeline in place. Along with that, the predictions needs to be determined. For it means that all of these 100 million plus devices needs to be monitored and predictions need to be made within 5 to 10 minutes of the time when the data will be coming inside it. So the latency needs are very large. Along with that, to process these kind of data sets, like 100 millions of these kind of a data sets, even a large querying system will fail. So you cannot have like a one large table and you can actually write a SQL query on top of it. You need to use a sharding mechanism and a lot of other mechanism, even just to understand how the data looks like. And along with that, a lot of ML models, we need to run it on the edge. And for the edge, their RAM was less than 1 gig. So it means that, okay, and along with that, the storage was like few megabytes itself. So what we are saying is that, okay, the overall challenge is even to deploy the model, even getting the data, understanding the data, and as well as deploying the model on the edge, that actually impacted end-to-end ML model development, starting from problem formulation to the model development. One use case, another use case, this came from the marketing. It's on the churn prediction. We say that we're working with one of the insurance company, and they actually want to work on a subscription based model, like identifying customer and policies that can stay long for the policy, and just identify that okay, hey, what will be the lifetime value of an individual customer or anything else. So on an overall sense, you can say that okay, it's a supervised classification model. It can followed by the survival analysis. You can say that okay, yes, if this like a consumer or customer will leave after 20 days, 30 days, 1 year, 2 years, or whatever it will be. But the challenges that we were actually solving is that okay, the data we're getting for more than 100 million customers, and you need to run the offline predictions in batches. So in this case, latency won't be a problem. Large customer base, but the interesting point is data was coming from various systems, like transaction systems, account opening systems, CRM systems, and so on and so forth. Each and every system has a different protocol, different units, and different formats. So almost more than 90 to 95% of the time itself was taken to build a data preprocessing pipeline for all of these systems, connected together, and then solving a problem on top of it. So data preparation that we have done is with Apache Beam, but along with that, we have a lot of time series data. Processing time series data at scale just to make it available for the machine learning model development, it's another headache in itself, because a lot of features, a lot of functions are not even directly available in Beam that you can take it to pre-process it. For an example, if you want to add a lag or any sort of what I should say lead time to check for the autocorrelation or something like that, it takes time, like building those things, testing those things out. It will not be just like adding -1, running SQL query, and your data will get ready. One another problem that we actually solve is for the document processing. Like for an example, if you're processing documents from KYC, mortgage, loans, and bank statements, it actually takes a lot of time, and a lot of organizations they actually try to solve out these kind of challenges to minimize their time and verify that okay, hey, if we can actually make this process automated, you can say yeah, the solution looked very direct that yes, computer vision plus NLP based systems we can use both spatial and text features. On top of it, we can build a rule-based systems or fuzzy matching system or anything else. We can process like a different pre-processing at different document level, and we can have like a wrapper on top of it for any enhancement model. For example, I say that, okay, hey, multiple parsers available for various document types. I will be extracting entities out of it, matching it, pushing it forward, and then publishing it. Looks feasible, yeah, but the challenge is that we actually worked on that we need to support various image formats: PDF, TIFF, JPG, PNG, docx, excels, and so on. So pre-processing itself becomes very challenging and very critical, and we really struggled very hard on that. Along with that, documents had various timestamps. Like for example, some of the documents we were directly getting it from India region, some of the documents that we were actually getting it from US and EMEA. So those kind of a various time zones, various kind of timestamps, processing various those kind of a things, even determining that, okay, yes, what time zone it is in, that's going to be like a very big challenge. Along with that, a lot of these kind of a financial services customer, they have a lot of legacy systems. So it means like even you will feel a lot of these systems are coming from, or they are using COBOL or Perl or those kind of languages. So just forget about AI/ML. Like just to ingesting the data, processing it, converting into a real format, that becomes a big challenge. And along with that, how you are actually generating those predictions, your final output, and even to build a model after this kind of a pre-processing, that's very challenging. Along with that, latency and throughput, it's again like another deal breaker. Processing like 200 million documents per year, it's a huge what I should say challenge, and very interesting problem to solve it. So it means you always need to trade off. You say that, okay, hey, yes, I can deploy a largest of the GPU. You'll say that, yes, I will deploy the best A200 or those kind of a GPUs, and I will be able to reduce the latency. Yes, you can do that, but overall cost will go up. Typically, these kind of a companies, they are like spending 20 maximum like $10 to $12 per document to process. And if your system is actually taking like $20 to process, you're not providing any value to the business. So even if your system, your models are really good, they're not going to add a lot of value. It will become a very cost center thing for these organizations, for these companies, and they will drop it. uh, One of the last use case that I want to share, it's on the healthcare side. So one the very interesting problem that we're solving on radiology and pathology. So it means it is very like identifying anomalies in these kind of an images for radiology and pathology is very common phenomenon, and it's very widespread use cases to determine any disease or any discomfort with a patient. In these kind of a use cases, like any misses or false positives, they cause a very significant impact, because you're talking about the preventive care or patient care over here. So you can say that, okay, yes, the solution will be, hey, it's an image. So we are actually working with 3D DICOM image. You can take a computer vision model. You can build any model on top of it, like a SqueezeNet can be one of the model, 3D model. Or you can say that, okay, you can actually slice those images into 2D or small cubes into the 3D. And then you will be using some localization methodology to determine your region of interest. The challenges over here is that, okay, the labs who will be actually using these kind of systems won't be having these kind of very strong internet or strong machines. They will only be using uh, their regular CPUs, their regular computers to process these kind of images. So it means you will be deploying those models on the edge. Those models, like these kind of systems, will not be calling your server to generate those outputs. So you do not have what I should say a luxury of building 15, 20, or 100 gigabytes of the models. You need to be very cognizant of those limitations. Along with that, these kind of a 3D images, they can actually sometimes go in gigs with the quality of the images. Even the largest machine in the world cannot process that full image at a time. So you need to slice it out, you need to dice it out, and you need to actually work on a lot money, those kind of things. Along with that, typical class imbalance thing, you can say that, okay, hey, the number of positives, number of negatives, those proportions are not very great, and their actual impact will start impacting the model quality as well. Along with that, whenever you're building those things, you need to be very considerate of the compliance and the regulations, what kind of a models that they are habituated to, how you're going to explain it. Model explainability is another feature that will be directly coming out of it. So it means that, okay, hey, how to be like your model to be compliant of it, how, what kind of a regulatory approvals your models will be needed, and so on and so forth. You need to be work according to that framework as well. So you cannot be just building anything out of it. These are some of the use cases, not just the limited ones, but that, okay, yes, how the real problem actually got multiplied and magnified if you're solving a problem at a scale, at a large level, versus if you're just talking us like solving a small experiments on a small sample. And you will feel like that, okay, that path is not a path at all. If the only thing is whether you have started solving a problem thinking at a scale or not, you cannot say that, okay, it's working on a small sample and then I will just extrapolate it and it will start working on the larger sample and the full data set. That's not going to happen. And it's a very, very, what I should say, classic case where you will see a lot of failures will happen. And the effort to go from that small scale to large scale, it's huge. It's almost like building everything from scratch. That's a lot of what I should say material. This is my last slide. So it means that, okay, some of the questions that you need to be asked. This is like an old school PPT framework: people, process, and technology. So it means that you need to focus on who is your end user, who are going to use it. Before even writing a single line of a code, you need to understand what's the customer journey are, who will be your final user, how they are going to interact and connect with these kind of models, why they are going to use it, and where they are going to use it. Ask those questions, understand their user behavior, only then start framing a problem that, yes, what's the problem that you want to solve for. And to do that thing, you will need a business and domain knowledge. So learn about those things before like starting delving into model development. This can be done either like processing the data, understanding the data, or like connecting with the right business people. Second thing is about the process. You need to like create a robust end-to-end system design, like that, okay, yes, considering that, various inputs, various output schemas, various limitations of the systems, regulatory and compliance framework. Build an end-to-end system design, and based on that system design, work and build models on top of it. Do not even jump that, okay, hey, I have the data, let's start building models. Don't do that. Start with a robust end-to-end system design, where the data will be coming in from, what kind of a connections will be needed, is it going to be a polling or not, from where the data will be coming in, how the streaming will be looking like, what kind of an algorithms that will be actually capable and robust enough to use in these kind of a scenarios, where it will be deployed, how the users will be using, and so on and so forth. Take the inspirations from the already built systems within the organizations that are currently into productions. No need to take this thing on your ego, like on your ego. Identify the similar systems, take the inspiration, take like copy it, copy paste it, try to utilize as much as those systems you can, and it will actually solve a lot of regulatory compliance and process hassles for you. Along with that, set up the development process and follow it by heart. Don't say that, okay, if you're using like name of the variable as a, b, c, or x, y, and z, but it's about that, okay, yes, no, this is my snake case or a camel case, I will be using git, these are the code reviews, and so on and so forth. Build that sort of a governance process from the day one and follow it by heart. Technical debt, it looks very interesting from the outside, but it's scary when you actually start working on it. And finally, it's about the technology. Select the right stack that should scale up as per your needs. Select the stack so that it can scale up as your business requirements. Talk about that, how your business will perform 4 or 5 or 10 years down the line. Will this technology will be able to scale things up? Marketing pitch, use Google Cloud. It's an awesome technology. Consider about like continuous ML training, ML ops from day one itself. You should be having that as a part of your system design, that yes, how you are going to train those models, how you're going to serve those models. And finally, build a rough pipeline as soon as possible. From the day one, in parallel to the data experimentations and everything, you should be actually building these kind of rough pipelines, so that you should be able to experiment faster, you should be able to fail fast, and you should be able to get that, okay, hey, what are the challenges that these kind of a pipelines will face while deploying these models, processing those models into production. So that's my last slide. I used to write a lot on LinkedIn. Experience from the field, like this is my hashtag that I actually use in all of my posts. So if you want to read all of my posts, you can actually go to this hashtag. You can follow me on LinkedIn, NTN Agarwal. That's NTNAGGARWL. That's my handle. You can search my name, Nitin Agarwal. I am currently leading Cloud AI Industry Solution Services team for Google Cloud India. So that's about my presentation. Any thoughts? Any questions? Anybody wants to ask?
Awesome. Thanks a lot, Nathan. That was awesome. Thanks a lot. That was actually a lot of information. And of course, like we'll be if you can share the slides with me later on, that'll be great. So I can put that on Google Drive and share that with people. So So everyone who's tuning in, you can find these slides in the description of the video. So once we are done with the conference, I'll be adding those information in the description of the video, which you can find on YouTube, and you can access all those slides. So let's now jump on to some of the questions. So I saw this question from Satya, and I found this very interesting. That how do you build scalable frameworks across multiple industries where the requirements could be different, right? So she's asking that when you were talking about the ML ops pipeline, right? When we are
Yeah.
trying to build these pipelines, the requirements would be different. The based on different industries, the use case, the data, as you mentioned, like some of that could be batch training, some of that could be sorry, batch scoring, some of this could be online scoring, etc. So how do we build these frameworks or pipeline which are more or less accommodating all these requirements?
That's an interesting question, Shorya, and thank you so much, Satya, for asking it. In my experience, this is the difference between your ML-based modules versus an SDLC, like building any other softwares. You cannot actually follow a one scalable framework that, okay, hey, this is like a panacea framework that you can actually use across the domains. Even if you say that, okay, for example, if you have built any one framework for a bank, it might not work for another bank, even like for another financial services industry. That's the reality of this business. So it means you need to determine that, okay, yes, what kind of a requirements. You can actually build a SOTA or a microservices based architecture. You can provide small those kind of a domains that can scale things up, but it requires a lot of customization on any of those frameworks. Uh, those like a trade-offs, it depends on the business, what kind of trade-offs that you want to make. Some of the trade-offs that what I have seen that, okay, yes, few of the customers, few of the organization, they even change their uh, mm, customer journey. For an example, if they are saying that, okay, hey, I will be providing a lot like all the outputs in 10 seconds, they say that, okay, no worries, I will tell this and change my customers behavior, that they will be getting all the outputs in 15 seconds. Another trade-off will be the cost. They need to understand that, okay, hey, the cost is high, but again, along with that, you're getting an automation, your maintenance is going down, and so on and so forth. So a lot of trade-offs, it depends what kind of a trade-off that you will be making at a user level, at a processes level, at a technology level, at a change management. So you need to determine. But at the end of the day, if any of the trade-offs, any of the scalable frameworks are not converting things into dollar values, I don't think that, okay, you will be getting really very enthusiastic response from the business.
Makes sense. That makes a lot of sense. So another question is, this is something which I'm also like curious to know about, is how do we manage security, right? Like where does that piece come into this entire pipeline from doing exploratory analysis to deployment? So where does the
Interesting.
security piece come in?
I'll say that, okay, we should not outsource security. Give it to Google Cloud. They're a secure platform. But the thing is, that's a good question. That, okay, yes, how to actually manage the security. There are a lot of frameworks. There are a lot of ways that are currently available. You can encrypt the data like at rest and as well as at transit. You can actually use your encrypted keys to do that. You can actually set a Bastion server so that you only hard code it. These are the IPs who can process the data sets and so on and so forth. Well, like creating some intelligent rules for firewall. Like my team also published that as a part of Forseti. You can search out for anomaly detection in firewall rules to determine any attack or not, like a DDoS or something like that. So there are a lot of way to manage a security. This is very broad concept. Like at what level you're talking about security? Are you talking about infra level? Are you talking about data level? Are you talking about application level?
Yeah,
So this is going to be pretty interesting. But I will say that, okay, use
makes
Google Cloud, man. Yeah, this is
makes
awesome.
sense. Nitin, one quick follow up on that, right?
Yes.
One of the things which I've been also reading a lot is about like model attacks, right? Like where the robustness of the model is in compromise. So how, like in your experience, right? Like so far the projects that you worked in, how often do you see that that's a point of concern, or like companies are want to make sure that robustness of the model, not just the infrastructure, or not the cyber security part of things, but
Mhm.
robustness of the model itself, like to make sure that there's no attacks on the model, or there's no like um, adversarial issues with the model. So how do we
It,
make
it
sure on that?
it's happening, Ashwarya, actually. Like those kind of adversarial attacks already happening. It happened recently in one of the bank at Dubai. The similar kind of, I will say that, okay, it's an attack that happened to one of the chatbot that Microsoft launched, that learned
Yeah,
some unexpected signals and
yeah,
some unexpected results. I will call it as an attack. because model
Yeah,
learned it from that.
absolutely.
So what I've seen over a period of a time that okay, if you giving a power to the model to learn automatically, it will always be prone to those things. Okay,
Yeah.
in my sense, we are calling it as an intelligent, but machine learning is a fool. It's the biggest fool on the earth. So it will just learn whatever you will give it to them, and
Yeah.
it will learn. Simple.
Yeah.
You will give something back to me. I will say that okay, no, I don't want to read it. But model will not discriminate. It will say that okay, no,
Yeah.
give me the data, and I will learn from it. Whether it's good or bad, that we need to
Yeah.
decide. That's
Yeah.
why in those kind of a things we are saying that okay, human into the loop, like automated, responsible AI, model explainability that coming into the picture. But
Yeah.
these kind of attacks are going to be a real thing. So we need to build that sort of framework that okay, hey, at what level we need to add a human into the loop, what kind of an automated test that we should be working on. So for one of the project that I worked on, that okay, we actually deployed some of the integrated and automated tests based on the model explainability. For an example, if those kind of features are moving here and there, if the distribution of features are changing by this much, we experimented with TCAV. It's one of the framework again to explain those models. So those kind of an automated things that we did, and any significant deviation, we are calling it as that okay, hey, model started behaving different. So before pushing that thing into production, a human must verify it. But again, those are the patches. I don't know at the
Yeah.
moment that how
Yeah.
this problem will be solved at a scale. We need something big and something automated.
Makes sense. Totally makes sense. So I wanted to pull out this other question. Again, there is no right answer. There's no one value answer for this, but this is a very, very common question, and I really wanted to address this. That like people even ask me that, hey, what is a good accuracy value that I should be targeting at? What is like what is good, what is not? So yeah, this question's for you, Nitin.
It's an interesting concept. Thank you so much, Mike, for asking it. I was expecting some similar question from you for sure. So the thing is, Mike, eh, anything that saves money for me. Okay, so if you're saying that okay, anything push this model into production, I'm giving, and this is giving you like 10% accuracy, but it will save you $1 million. I'm happy with that accuracy. So all these kind of like what I should say accuracy level, cost value trade off, they're very subjective. They're based on your business decision, whether you're targeting dollar values, whether you're targeting user experience, whether you're targeting or anything else. Like what are your actual targets? Based on that, you can actually define those accuracy level. I can share one my personal example. So we published one of the case study with Seagate. It's a public reference, so I can share it with you. In Seagate, we actually built a model. We got some precision recall value, and it got a lot of media attention. So one of the blogger, he like that particular media house, they republished it and they said that okay, hey, the F1 score based on this precision recall, they calculated the harmonic mean. It's around like 56%, and it's slightly working better than a monkey. The thing is that okay, that's the reality, yes, and we intentionally never published Evans score. But these kind of a metrics will only work when the cost of false positives are equal to the cost of false negative. If the difference is very large, F1 score will not work. Then you have to move forward with an F beta score or something sort of a business metric. So even in that case, F1 score was hardly like 53 or 56%. You can say 0.53, 0.56. We actually saved like a decent money over there for the far Seagate, and that model is like it is working very well. So it actually depends that yes, how to select those things. I don't have like any answer for that. I'm sorry.
Yeah, I definitely wanted to address this because this is a very common question that comes up, and we need to understand like that. There's no like one good or bad score for any of these cases, and there is no one metric which can be measured across any of the models. You can't say that hey, like accuracy is that one metric which you need to measure across all different kinds of models to understand if the model is doing good or not. So thank you so much for like clarifying that, Nitin. So this is another interesting question from Chaitanya, that in the pipeline that you mentioned, where do like data scientists come in and where do ML engineers come in? And again, like data scientists, ML engineers, all these role names are very different in different organizations. So I'll like let you go to that question.
Interesting. Thank you so much. Okay. So thing is, Chaitanya, thank you so much for this question. I already made some good controversy after sharing my thoughts on that. Again, disclaimer: these are my personal thoughts. Everybody has a different experience, but these are my personal thoughts. In my experience, data scientists they usually do a lot of research work. For an example, how to solve a problem, how to actually build a forecasting system, how that thing will look like. Okay, ML engineers will be the one who are the applied people who can actually taking those things and actually solving a problem. So it means those kind of an ML engineers will be actually taking the data, thinking about end to end long term, and then solving a problem, training a model, and so on and so forth. Some of the data scientists you will see that okay they will be doing that, but in my experience you can decide that okay whether you need a data scientist and ML engineers, but ML engineers will be more practical, solving problem, building pipelines, so on and so forth. Data scientists will be just trying that okay whether this problem can be solved or not, and then they will be determining at a statistical level that okay this makes sense. So that's a distinguish I will say. Where they will fit, you use your own imagination that yes in the project. So that's why like in our projects we used to have ML engineers and AI engineers. We do not use a lot of data scientists in the projects in the applied side, but again these is based on my limited experience. Don't quote me over there and say that okay hey Nitin are saying data scientists are not needed. Everyone is needed. Your call that to whom you want to work with.
Absolutely, absolutely. Again, like I feel like the terminologies right now is very absurd. What I have seen is like every company, every different industry have different names for different roles. So very subjective, like very subjective on there. So yeah, this was another interesting question we saw. So how do we monitor the drift in model accuracy metrics as to how this architecture could be designed?
Good question, Manish. There are a lot of pre-built, or you can say uh, uh, open source. A lot of packages are already available. A lot of systems are already available that can actually provide you capability to check the model drift. Very simple name. You can say that okay, hey, you are training a model. You trained a model. You got some sort of a precision and recall value. Okay, based on that, you are generating some inferences. On the inferences, you are testing few things. Hey, what's the distributions of? For an example, it's a classification model. You are just checking what's the distributions of positives and the negative class or zeros and ones. Simple. If that distribution is changing, you can say that okay, there might be a data drift or the model drift. So you need to define that okay, hey, how you're defining the drift. There are a lot of you can say open source packages, open source products, managed products. They are available who will check like using Bayesian methodology to check whether the model has been drifted or not, or the data has been drifted or not. But you need to determine as per your use case what are your needs. Sometimes these kind of only basic checks like that okay, hey, if you have a loop from the actuals, you're saying, for example, if you're working on financial services, you'll say that okay, you're working on loan delinquency. If you have the real-time feedback as well, whether that particular loan became delinquent or not, you can determine that yes, what's the precision recall of your model and has it changed over a period of a time or not. So there are a lot of ways, but you need to determine and you need to define that yes, what's the definition of drift for you.
Makes sense. Totally makes sense. Okay, let me see if there's any more questions here. Yeah. So one of the things again, like this is, I think, a question which is very widely asked on what's the stack, or like what's the tool set, or what kind of which language to use, which platform to use. This is a question which comes up a lot. So I wanted your opinion on this.
Absolutely, Manman, go for Google Cloud, man. Trust me, you don't need any you don't need anything else. Okay, but Manman, in my sense, a stack doesn't matter, right? I started my career with R, then I moved to Python. Concepts means the same. Technology changed a little bit. The way that I used to like write code, it changed a little bit. Model fit dot fit becomes like fit dot model, nothing more than that. So the basic remains the same. When I started the coding, I used to like build things on C++, C sharp.net, very basic optimization, those kind of a things. So it doesn't matter. But over a period of a time that, okay, what kind of a things that will be needed that's really suited for you for solving this particular problem, that becomes very important. But only comment over here is select a stack that can scale up as per your needs. For an
Yeah.
example, if you are processing 1 million data points and if you need to process 100 million data points, will this stack be able to scale things up? For an example, like Kubernetes are you using, or any other like query based systems, any other data warehouse? Just make sure that okay, that stack is scalable, nothing more than that.
Yeah. Totally makes sense. Awesome. So I don't see any new questions here. I think that's all the questions for today. Thanks a lot, Nitin. This was very helpful. And as I mentioned, the deck that Nitin shared today and the recording from today's call will be available on YouTube after the session. So you can please go ahead and refer there. If you have any more questions and you want to show them to Nitin, please feel free to connect with him on LinkedIn and like talk to him directly there. Awesome. I think that's all we had for today. Thanks a lot, Nitin, and it was awesome chatting with you.
Thank
Uh,
you so much. Thank you so much for having me here. Bye. Take care.
Bye.
Thank you so much, everyone.
Hey, so before we jump on to a quick break, I had something interesting for you. We would be having our next session in about 10 minutes. So we'll be having Alexander Baker deliver another session at 9 a.m. PT. Before going there, I wanted to go back to our trivia. So we'll be playing another question of trivia, and make sure that people who are tuning in from YouTube, please go to LinkedIn, because that's where I can see that's where I can see your name. That's where I can see who's answering in the most fastest manner. So the way we're going to do this is, I'm going to show you a question right now with four options. You have to say which one is the right option. So you have to say A, B, C, or D in the comments, and based on whoever answers the fastest and the correct option will be receiving the book Between the Spreadsheets by Suzanne Watch. So awesome. Let's brace yourself for the question. Here we go. So the question for today is, decision trees can be used for which type or types of models? Option A is regression. Option B is classification. Option C is both of the above. Option D is none of the above. So I'm going to give you 10 seconds and we're going to see who's answering this question fastest. So your time starts now. Okay, awesome. So the answer for this question is, of course, both of the above. Decision trees is an algorithm which can be extended for both regression and classification problems. If you would want to read more, please Google decision trees and you'll get a lot of information there. Awesome. So let's see, how many people do we have here? Give me a minute. I might have to go to LinkedIn and check on the chats there, because I have limited access to how many chats I can view on Raystream. So I'll have to go to LinkedIn and see here. Okay. Let's see. Oh man, there is a lot of people who have commented. it's gonna it's gonna take some time for me to see. Okay. Okay. Okay, let's see. I have to sort it by most recent, and then I can find you. Option E is not the option. Whoever chose option E, there was no option E. But okay. uh, how many people have commented here? I've been scrolling down and still not reached the end. Okay. It looks like Mandar Chaudhary, who's an applied researcher at eBay, is the one. He's gonna win the book. So I'm gonna comment on your post. Congratulations, Mandar. Awesome. So Mandar Chaudhary has won the book. Congratulations. And thank you everyone for participating. I would like we'll again be coming tomorrow with another trivia question. So you'll have two more chances to win the book. For tomorrow and day after, we'll be having the same trivia questions. I mean, like not the same question, but yeah, we'll be having trivia questions. Awesome. Great. So let's take a quick 5 minute break and come back here. We'll be having our next session exactly in another 5 minutes. So see you there. Hey, welcome back. I hope you had a quick 5 minute break, and now we're going to start with our next session. We have Alexander with us. Hi, Alex.
Hi, it's nice to be here. Thanks for having me.
Awesome. I'm really glad you could take our time to deliver the session today. I'm very honored to have you here.
Yeah, thank you. I'm honored to be here. All right. So I'll start on the presentation. Let me share my screen.
Yeah, sure. A quick introduction about Alexander. He is currently a senior data scientist at KPMG, and he has experience with working on federal projects. Maybe do you want to just give a quick introduction about yourself? Like, how was your experience, and how has it been going working on federal projects?
Yeah, absolutely. So I started initially working in the federal space at a company called Booz Allen Hamilton, which is it's a really famous federal contractor in the United States. I don't know how how big it is worldwide, but it was a pretty it kind of got me into the whole government industry because I feel like it's one of those industries that's the most important to have data scientists in because the federal government's very far behind in terms of a lot of technology. At least the United States federal government's very far behind in terms of technologies and processes and um, and proper change management and everything. So it's always important to have young tech professionals, young and old tech professionals in these spaces in order to have our federal government keep up with the times and ensure that they're employing the most up-to-date technologies possible and to increase their efficiency. So that's kind of the reason why I've joined the federal space, and it's kind of why my career has been led in the way it was. After I worked at Booz Allen, at Booz Allen. I worked with the DHS for a little bit. Then I got to do some work with the FDA, where I was introducing a lot of natural language processing pipelines. Into their system in order to judge whether a device would be faulty or not based on their descriptions. And then at KPMG now, I primarily work a lot on Air Force base mapping and trying to identify like the best possible living areas for the United States Air Force members as they move from one base to another. That's kind of why that's kind of what sparked this project in particular. This Basically, like, I have to do a lot of mapping in my current work, and I was thinking it's kind of an underrated skill because prior to this I haven't really done a lot of it, and there's so many geographic libraries out there, and geographic data is becoming increasingly important as certain projects become more popular. Like global warming is probably one of the best use cases for this skill. So I would love to give you all an introduction to geographic mapping and what I've personally learned on my geographic data journey. So without further ado, I'll begin. Thank you. Sorry for the
Awesome.
long-winded introduction.
Awesome, awesome. Also, like, if you have any questions to the audience, if you have any questions, please feel free to put that on the chat. And Alex, let's try to like maybe pause in like 7 to 8 minutes. Just go through the questions if we have any, and then we can continue with the session if that works for
Yeah,
you.
that sounds great. That sounds great.
Awesome, awesome. So let's start with it.
So, so basically, my goal is to give you all an idea of the basics of map creation in Python. So for this particular project, we'll be using matplotlib for like the meat of it. But as we go further, I can teach you some other fantastic mapping libraries, and there will be a lot of a lot of code involved. So I'll try to get through the text part of the presentation as quickly and painlessly as possible. So first, you might ask why we want to create maps in the first place. So maps can be very useful for data exploration in particular. They're very intuitive visualizations that your audience will immediately understand. And for example, if you color a certain area, a certain area on your map, then your audience will immediately know what's associated with it. So it adds a dimension to your graph that almost all humans will be able to understand instantly, because we all have this intuitive understanding of geography, of latitude and longitude, of air, of where things are and how the world looks. So this kind of creates a connection with your users that most other data visualization techniques just don't have. And it can be used to display like a lot of results very quickly and easily. So moving on, the fundamentals of mapping. So basically, a lot of maps or geographic data can be presented in latitude and longitudes, and you can make it that way. But a very easy way to make your maps is to find what are known as shape files. Shape files are essentially these vectorized files that are provided within a zip that can work in tandem with a library called GeoPandas. And by using these libraries, it's a very easy way to incorporate simple graphing techniques into your projects without having to do a whole bunch of extra code that you would have to do otherwise. So when using a shapefile, there are all these other types of files in there. Since we're limited on time, I won't go over them individually, but the .shp file is the one that is the most important one. However, it cannot run without the other files within its zip directory. So the .dbf, .shx, .prj, and there are numerous other ones that provide extra information to that shape file that will give GeoPandas an um, additional information that it will definitely need in order to create your maps. So when using GeoPandas, all you have to do is just use your GeoPandas frame and then the .plot command, and the GeoPandas data and the GeoPandas plot will come about easily. So as I come to this, let me show you a good representation of all of this in practice. So you import all the libraries, and you can see here what's really, really cool about GeoPandas is that it can read in entire directories as a zip file. So if you want to only use one singular file in there, you use the .shp file. But the zip file, it provides so many useful applications for getting these directories directly from the internet and bringing them right into your project. So there's no need. I downloaded this for the sake of simplicity, but there's no need to actually download these files because you can navigate to the web pages that contain these zip files and just read them in automatically. It's a really, really useful application of GeoPandas. So once you go into I'll explain the rest of this later, but once you download this in, all it takes is this .plot method, and you instantly have your GeoPandas plot right then and there. So essentially what it's doing with all those extra files, it's creating all those extra files, give it the proper information to immediately plot your zip file with one command. It's really, really cool. And I'll explain the rest of these matplotlib functions later because they're very useful. And once you learn them, you'll use them for all your matplotlib graphs. So once you have that .plot command, you can actually use the column parameter to add an additional numeric column to each of your geographic areas. And the CMap attribute will be able to change your color scheme. So let me show you exactly what I mean. So all of this up here is essentially me adding additional attributes that weren't previously in this shape file. So what's really nice about a GeoPandas data frame is that you can use it as a regular data frame and start merging other variables in that you would potentially like to take a look at. So previously I merged a population file in. So now by using this column function, I'm able to see I'm able to color my map exactly like the population. So the higher a population is, the more the color leans toward yellow, and then the lower the population, the more it leans toward purple. Um, so this is a really cool application of this column function, and it makes it very easy to plot fantastic maps like this on a linear scale. And what's really cool is you can all you need to do, if you don't like this color scheme, I believe this one is plasma. If you don't like this color scheme, you can just use this CMAP function and choose from a variety of ones. And I'll even teach you how to make your own color schemes later in the presentation. I guess this is a great time to ask questions because we're at the point now where we've already established how to create these maps. Oh, and as a little bonus, this boundary function, if you only want the outlines of each country while not containing any of the filled in polygons, all you have to do is just use this boundary function or use this boundary attribute, and you'll be able to only get those boundaries, so you can fill in each of them while having the advantage of distinguishing country boundaries. Now, I'm going to stop for a brief moment and ask if there are any questions from the audience. Sorry. Hello? All right. Aishwarya, are there any questions for me, or
Hey,
should I?
yes. So
Yeah,
let me
okay.
pull that up. Okay.
Excuse me?
Yeah. Sorry. Can you hear me?
Yes, I can hear you.
Okay. Awesome. So I'm just like looking at the questions that we have here.
Mhm.
So we have a question about like how does it work with the geodatabase file? So that's what Philip is asking.
Gotcha. So typically, if I remember correctly, a geodatabase file is well, there's one of the files incorporated within them are database files, but I would definitely need to test that out in order to get an idea of how it works in a geodatabase file. Um, with a geodatabase file, because currently I haven't necessarily had the privilege of trying that yet.
Okay, awesome. Yeah, I think that's another question is can you do the same with a raster image? Is what Aparna is asking.
With a what image?
A raster image.
A raster image?
Yeah, for some reason, like the chat is not coming on to restreams, so
Mhm.
I'm not able to like show that to you. That's why I had to go to LinkedIn and see what's coming up. Uh,
Gotcha.
Let me see.
A raster image. Is does a raster image include some type of geometry, or indication of certain geographic points, or sorry.
Let me put that for Aparna. Give me 1 second. Uh, does it include geometry? Or what did you mention?
Any type of points, because as long as it includes some type of latitude and longitudinal points,
Mm-hmm.
you can use GeoPandas with it.
Okay, got it.
Unfortunately, I don't know what a raster image
Mhm.
is. My
No worries. I've put that question for her. So
Mhm.
let's see when she's replying to that. I think so far that's all we had. So you can continue with
Yeah.
the talk.
Yeah, to answer all of to kind of catch this in an overall net, as long as there's some type of latitude, longitude, geometrical points, or some type of geometry, you can actually turn it into a GeoPandas frame, and you can use it with this. So, in terms of all the data types, if it has those specific points in them, those numerical points, you can turn that into a pandas data frame. So great questions. Sorry, hopefully that answers those questions. So thank you all for asking. So going on from the basic mapping, you can create custom color maps using a library called Branca. And using this library, you can create both your custom linear color maps based on a continuous variable, or you can create specialized step color maps based on certain thresholds that you use. So, and also if you don't have a specific color, like if there's a color that you want that's a little bit more detailed than just simply red, blue, green, if you want like a specific tone of red or a specific tone of blue, you can actually use, this will take hex codes as well to color it. So just a fun little, if you want to play around with that, just a fun little method of using this. When we visualize our machine learning model, I'll show how we do these color maps, or I'll show you how to do these custom color maps. So in this specific example, I just wanted to show how machine learning can, like one potential way of incorporating machine learning into this map. So into a map. So for this specific example, what I wanted to do is take a k-means clustering model and color all of the countries group all the countries based on their area and their population. And by establishing these specific groups, I want to color in each country on the map based on it. So there are far better uses of machine learning, but this is kind of getting the ball rolling to basically plant those seeds in your head so that if there's a certain application you would like to see with this, you can say, oh, well, maybe I can group countries by temperature change and then plot those. So let me show how it's done. So so the first thing I want to do is isolate the metrics that I want and start exploring them a little bit. I created my my scatter plot to see how area and population match up. You can see that there's a lot. There are problems with this data. There are a lot of countries grouped down in the lower left-hand corner, and you can see the standard deviation and the spread is clearly not consistent. But this is just for the sake of the demonstration. We will be using machine learning. There are uses for machine learning that kind of expand on this. So then I create the clustering map. I feel like 4 clusters was a very reasonable amount. You have your small countries, small populations, medium countries, medium populations. You have your large countries, small populations, and your large countries, large populations. So going down here, I wanted to create a color map. So what's cool is I'll teach you how to automatically do this with Branca later on, but for this, I'm just creating a manual color map. So what I do here is establish my colors, establish my IDs for the colors, create a dictionary based on that, and then we have our color map here. And then we code each of the groups based. So we already grouped each of our countries with that map above, or with our machine learning model above. We map each of those countries onto their labels, and then we create colors from those labels. So now we go here. Let's visualize our results. So we see, as expected, there are a lot of small countries, small populations. There are like a good amount of large countries, large populations, small amount of medium countries, and small amount of the large countries, low populations. So you can see how each of the numbers are grouped right here. Pretty exciting. Right here. Actually, this seems like number 2 seems like it would be more of the medium, and then number 1 seems like it would be more of that, more of the larger ones. And then of course, like number 3 is very small. This is definitely Russia. So we join it all together with our geodata frame, and then we plot it. sorry for the color scheme. It's a little bit it's a little bit rough, but you can see how each of the countries is plotted out, and you can see how each of our assertions based on what we saw is mapped. You can see the green right here for the large countries large. You can see the red for the smaller ones. But now it comes to the fact that we want to see legends on our graph, because this is all good. This is all good, but it's not very fun to just do this from memory, right? So adding legend, so that kind of leads me into my next plot, or into my next talking point, which is what do you do if you want to add legends to your graphic? What's really cool is there's an automatic way to add continuous legends to your graph. So all you have to do is just say legends equals true, and then add in what you want your legend to look like, as well as where you want it to go, and then you have your legend right here. And then if you want to create your custom legend, this is a really cool trick with matplotlib. So matplotlib, it's very difficult to create legends in it. So if you want to create your custom step legend with matplotlib, using this line 2D command can create these little tiny lines. You can create them manually by creating a list of lines and a list of what you consider the numbers to be. So you create your lines and your numbers, and then you group them together, and then we have our legend right here. So now you can tell which one is which group corresponds to which country, which is pretty exciting. Now you can actually understand what's what's going on. You don't have to memorize it. Yep, Russia. Russia is the blue one. So yeah, this is a pretty cool application of machine learning, and there are lots of other ones that you can consider um, that you can consider in your professional career. And I highly recommend experimenting with this, because this method of displaying your results can have a very it's very intuitive for your client to understand. So not everybody will be able to understand the intricacies around k-means clustering and what happens, but everybody can take a look at that map and instantaneously understand like what the results are and how certain countries were grouped based on that. So it's a really, or how certain groups ended up. So it's a really cool method of displaying your results. So now you're wondering what I mean by matplotlib fundamentals. Like, what are all of these commands that I keep on repeating over and over again? Well, this is a part. Actually, before I move on to this, I would like to ask if there are any additional questions that people would like to know, because I just covered a lot, and I would and that was a
Yes,
lot to
absolutely.
chew on. Oops, sorry.
So we have a question from Mike, and for some reason, like I'm not able to overlay it on Restreams because I'm not able to get the live comments there. But looking
Mhm.
at LinkedIn, like I saw this question from Mike. He's asking, like, when you're building these maps, right?
Mhm.
And when you're trying to integrate that with a model and like through a dashboard, does it have to be live data sets, and does it have to be like dynamic real time or like live data sets, or can it be batch processed?
It can be anything you would like.
Okay,
What's
awesome.
really cool is that these models are very flexible. You can update it live. You can update it using live data sets. You can use only batch information. You can use data sets from the past. It's very flexible. A good way to think about it is like this: any data that matplotlib can handle, this can GeoPandas can also handle. Um,
Yeah,
so you can create these machine. There's an incredible amount of flexibility with this. So you
got
can
it.
create your machine learning models with any type of data you choose. It definitely will work on live data sets. You just have to set up the pipeline properly.
Okay, makes sense. Awesome. Yeah, that's the only question that we had. So we can go ahead.
Awesome. So you may be asking yourself, what is this PLT subplots 1 fig group X? Like, why do I keep on repeating the same command before each graphic? So This is a very cool method in Matplotlib that I can't believe I went so long without. Essentially, this allows you to turn the figure and the axes into its own variable that you can manipulate. And this comes with an entire plethora of properties that you can manipulate for your matplotlib graphs. So a good one is you can set your figure size with this. This is also how you can plot multiple different graphs on the same axis and overlay them in order to create and overlay them in order to create an effect. So if you ever had, for example, if you ever wanted to plot a singular point on a bar chart, or plot some kind of box whisker plot overlaid with a bar chart or a histogram, this is essentially how you can do that with Matplotlib. So I'll show you some examples of these overlays later, but this fig and group X subplot is a very underrated command that I feel like is not really taught a whole lot in a lot of data science courses. So the next time you create like a matplotlib graph and you're stuck on how to get exactly what you want, look into the custom properties that come with this figure and axis variable that come from the subplot. Um, yeah, the subplots command is more useful than just creating subplots. It can give you full control over the style of your graph as well as the axis and the figure size. It's excellent. So I recommend looking into that, because if there's a problem with your graph or something you want to do that you're stuck on, this will definitely give you exactly what you need. And this will very much come in handy later. So now this is kind of where I get into a little bit of the technical stuff, a little bit of the confusing stuff. So when creating your own, so basically in this, I'm going to be overlaying plots on top of each other. And it's very easy to do this type of thing if you have regular data. But the problem with using geospatial data is where the earth is essentially a three-dimensional object, and geo and latitude and longitude points or coordinates are points projected onto a 2D space. So we essentially take this 3D place, we project it onto a 2D space, and then we have a metric system for identifying what goes into this space, or identify where things are in this space. So as a result, there are tons of different coordinate maps that we can actually use there are tons of different coordinate mappings that go on into this projection. So it's always essential to make sure that we are using the same coordinate system if we're overlaying plots on top of each other. So essentially, without this, a point in a certain space, say for example, you want to locate DC on a map, right? The DC coordinates, keep in mind, this is just like an example, but say like the DC coordinates are like 40, 60, for example. I'm probably way off, but say like 40, 60. On one coordinate mapping, DC will be located at 40, 60, but on another coordinate mapping, DC could be located at like negative 150, 120. And as a result, when you overlay them, your maps won't display the information that you intended. So it's always important to keep that in mind, especially when plotting polygons and points, and as I'll show you backgrounds. So let me show you so when creating these backgrounds, a great library for doing this is called Contextually. This is essentially us adding a background to our group mapping. Contextually is how you can create these backgrounds. And not only do they make your map look fancy, but it can add additional context to your mapping that otherwise wouldn't be available if you just plotted the shapes and points directly onto this map. And the reason why I went on that whole blurb about coordinates and about coordinate mapping and projection onto 2D spaces is that you always have to establish what kind of coordinate system is this background is going to take up in order to have it accurately display information onto your graph. So if I didn't establish this coordinate system using this ESPG 3857 in the 2CRS line, then this, I believe, I thought that the coordinates would automatically match up before, and they didn't. And this was nothing but a bunch of outlines over over a giant picture of Antarctica. So it's very important that you keep this in mind when you create backgrounds or want to overlay your geographic plots and everything. So let me go down here. So the adding background. So contextually is a great method to do that. The dot add base map function is the main command in contextually to add your maps. You can see that right here, and you apply this directly to this to the axis variable, and that essentially is how you overlay it. So if you're wondering why I went on that whole rant about the fig and the subplots, you need that axis variable so that contextually can identify which graph to have this background map on, which graph you want this background map to be overlaid onto, or you want to overlay your data onto which graph. And this source command, there are lots of contextually backgrounds that you can play around with. I'm using Stamen Toner Light because it's the easiest on the eyes, in my opinion. OpenStreetMap, I also really love it, but it's a lot of fun to play around with this, and I highly recommend it. Little warning if you're using the Contextually app is this. This library does have will have some security issues if you're using some type of highly protected computer. There's typically you have to deal with some SSL issues. If you're in a situation where you're programming on a government laptop, or you want to create a graph on your work laptop, it may come into conflict. It may come into conflict with you. There is a method to turn that SSL off. I recommend somebody on Stack Overflow gives you the specific line that you want to look for and set to false, and you can in the library, and you can immediately turn that off. So probably won't happen to you, especially if you're just doing these projects for fun, but just a little warning ahead of time. So now let's go back to plotting points and polygons. So now we're into the part of the speech where I kind of want to talk about creating your own geographic map. So this is all fine and good. We have actually, while I'm here, before I move on, I would like to ask if there are any questions from anybody.
I think we're good so far. I think there was one question from Aparna. She was asking, will it work on open line geometrics? So
Open
any
line
kind of
geometrics.
so I think what she's mentioning is like any kind of geometry that's not closed. So if it's not like a closed geometrical shape, will it
Mhm.
work on those kind of cases?
Yes, it will.
Okay, awesome,
Yep.
awesome. Yeah, that's
Um,
the only question so far that we have.
you just have to make sure that it's a line and not it's set. So actually, that I'm very happy that that question was asked, because that leads perfectly into the next one,
Mhm,
where where I talk about like plotting points and polygons and creating your own shapely spaces.
mhm,
Shapely has a lot of, so Shapely is essentially how you create a custom plot for GeoPandas. And in this demonstration, I only use points and polygon, but if you want to make sure that you're plotting like an open shape, I would use a line for something like that, almost to establish a path. So, excuse me. So for points and polygons, um, so Shapely can take latitude and longitude and create geometric objects from those, and you can essentially turn those into a geodata frame and then plot them onto your geometry graphs. And you can even save them as and you can even save them as geometric objects or as geodata frames with all of the special files automatically written. It's really neat. So again, the only thing you have to worry about, or one of the things that you have to worry about, is this point right here. So again, when I went into that whole rant about the 3D and 2D, you always have to make sure that your coordinates are properly calibrated in order for this information to properly display. So if you want to see how it works, an example of how I was doing this right here is to turn a bunch of cities. I took the city DF. I turned a bunch of cities using the Shapely point object, and I plotted the cities onto this base map. Again, remember, I had to use the proper ESPG in order to do this, but I plotted it onto the base map by turning these cities into a Shapely object first. So now if you want to plot the cities and boundaries together, you take you plot the city axis, you plot the boundary axis, you put them both on the same and then you can see the plot right here. So yeah, it's pretty cool putting it all together, overlaying them. It's pretty neat. Um, if you want to get more into Shapely, this is an example of me using some polygons as well as other geographic packages in Shapely. So I guess before I get into that, I'd like to first talk about what I plan on doing. So um, convex hull is another really cool method that I call it math magic because it is very, very cool to use, especially for filtered points. So essentially what a convex hull is it's the lowest sided polygon that can encapsulate a set of points. Now, you may be asking, why is this relevant to geographic data? Like, how can I use this? Well, say you have a certain area that you would like enclosed and highlighted on your maps. Convex hull is a fantastic way to do that. It is flexible, it's easy to use, and it's part of SciPy, so you probably already have it installed right now. And what I like to do is use convex hull in tandem with Shapely in order to create some really cool enclosed areas on my map. So moving into other additional libraries. If you're in the U.S., the import US the U.S. library is a really cool resource for finding data sets for finding geometric data sets that you can plot. So in this specific example, there are so many types of geographic data sets that you can have by just naming your state and the state files. I recommend playing around with it, or if you're I believe you can look to see if Python has a certain library for wherever you live or whichever country you live to try and use these libraries. Since I live in the U.S., I looked into the U.S. library, but I recommend like searching for more because these geographic libraries are such an easy way to get this geographic data that can make your mapping process very simple and straightforward. But for this, I wanted to look at zip codes. So what's really cool is all these zip or shape files can be accessed from this library and instantly read into your geographic data frame. Remember when I told you all you need is a web link and you can read the GeoPanda and you can turn it to a GeoPandas data frame? This is essentially just a collection of web links in this library, and I just read directly into the GeoPanda frame, and boom, we have our very own GeoPandas data frame, and we have a full zip coded map of Virginia. If you all want to know why I picked Virginia, it's my it's my home state. It's my home state. It's where I grew up. So Virginia was my default, but of course this can work on other states if you're curious. And another really cool library is PyZipCode. This comes with a lot of extra information that can be very useful, and a really cool function that allows you to get zip codes within a certain radius around a certain zip code. So 20120 is my zip code. Sorry, I'm not going to tell you where I live, but you have my zip code. And I wanted to get 10 zip codes around this. So all I need to do is just say for each zip code in this, get this radius, and then get the zip code from the entities that are located within that. So PyZipCode is really, really cool. It has like population densities, I think income, gender makeup, so many useful statistics you can use for your mapping. Like, I can't recommend PyZipCode enough. All you have to do is just initiate this base and then take the zip code right here. So going on to the actual use of convex hull. So here with convex hull, I get the latitude and longitudes of each of the points. And then what I essentially do is I create a point list aggregating the latitude and longitude. Convex hull doesn't work on geometric objects, so you have to get a little bit creative. And then I turn them into float, and then I got convex hull will find the polygon around that. Or essentially what convex hull will give you is it'll give you the vertices of the polygon around it. So so basically what you do is you go through the vertices, find the corresponding latitude and longitude of those vertices, and then turn those points into the polygon. So that's the trick to using the convex hull library. And then I use Shapely to turn it into a polygon. And then I turn that, remember the, say your coordinate system. I use and then I turn that into a GeoPandas frame. And then I plot it right here in red. So you can see the polygon around the zip code that we had. So now you have an idea on how to make polygons, but what if you want 2 polygons instead of just 1? So I refactored my code to become since we're reusing the same code, I refactored it to become a function. I call this function twice, and then boom, with different 110, 120, and then boom, we have zip codes in the 20 radius and the 10 radius. So before I finish out convex hulls, you're probably thinking this is a lot of hoopla for just the simple polygon. Like the developers of GeoPandas, of Shapely, of the Python developers had to think of a better way around this. Well, they did. Make sure you import WKT from Shapely, but Shapely actually already has a convex hull associated with it. It just is kind of wonky to use compared to the other ones. I know it's really strange. It's not very straightforward. You need to establish this as a data frame before, and then and then apply the WKT loads to it. So basically, when you establish your Shapely polygon, you just use this convex hull.wkt command on it. However, what ends up happening is you need to ensure before you load it, it doesn't. The WKT creates like a different object that won't load directly into the geometry data frame. So what you have to do is you have to ensure that this is an object that the WKT can actually handle, or the data frame can handle. And then once you ensure that, it'll load into the data frame just fine, and you can plot it right here. Finally, we want to export our file. All you have to do is just indicate the shape file and just use the to file. Excuse me, sorry. Just use to file, indicate the shape and the name of your file as well as the directory, and then it will automatically give you all the files you need, and you can immediately read it back in. So that's the matplotlib portion of it. Since I have 15 minutes, I'm going to go on to the stream, how to incorporate this into a dashboard. Does anybody have any questions before I move on?
Hi, yes, Alex.
Yeah.
So one of the things is when you're talking about like any kind of maps, right? So these are like
Hmm.
preloaded maps that we're working with. So what do we do if we have to like build any kind of custom projections, like any kind of custom uh, plot on which we are like plotting these latitudes and longitudes. So how do we
Mhm.
use any kind of like custom maps or like custom drawings?
Gotcha. So that the trick to that would be Shapely,
Okay,
right
got
here.
it.
Yeah. So so if you have those, sorry, I guess the point was a little bit muddled with all the pre-made data frames I was using, but Shapely can be used to create those polygons for you and then turn those into geometric objects that you can immediately plot onto your that you can immediately turn into a geodata frame and plot on it and then create maps of.
Okay, makes sense. That totally makes sense. So one of the
Yeah.
other questions we had is that will it accept all types of projections, or does it have to be only in latitude and longitude format?
um It should accept all types of projections, but you have to make sure that it it is an acceptable geometric format. I believe the documentation does have its limitations,
Gotcha.
but it can be like multi-point, polygon, line, point. I believe like square, triangle,
Hmm.
potentially.
Yeah.
It can accept all of the different types of shapely objects.
Hmm.
But the ones off the top of my head that it will definitely accept is multi-point, polygon, point, and multi-point, polygon, point, and line.
Awesome.
Which
Okay.
it's very hard for me to imagine there's a different. I mean, oh
Yeah.
yeah, and I believe there's also a circle command too. It's hard for
Mhm.
me to imagine there'll be an instance where you need something outside of that. But if you do
Makes sense.
look up the Shapely documentation because it could have it.
Sure. So I hope that answers the question, Aparna and Manish. Yeah, I think that's all we had right now.
Excellent, excellent. So what I want to do now is all these static maps are cool and all, but it would be really nice to see how you can. Sorry about this. It would be really nice to see how you can implement these graphics into a dashboard. So what I have done here is I've created a Shapely dashboard that can that can essentially take in these points and create some dynamic and interactive maps that you can use. So, if you don't know, Streamlit is one of my favorite libraries of all time. It's a very useful dashboarding library that is extremely intuitive for anybody that knows Python. Basically, all you have to do in Streamlit is understand how a certain widget works, and then you can pretty much use that widget as an input variable, and then use typical Python code to pre-process that input. So you all know the point of this. Like, so what I'm doing here is creating this dashboard, right? Let me show you. So let me choose a different state because you all probably are tired of looking at Virginia. So I have the state of Alabama here, and I have the Shapely graph. And if you see this point in polygon right here, this is essentially a way to look up a zip code as well as the area, as well as visualizing the area around that zip code. So right now, the zip code we're looking at is 36530, and we're looking at 10 miles around this radius. Sorry if you're, by the way, sorry if I'm using the word mile instead of kilometer. um, I'm basically a certain level of distance around this. That just so happens to be 10 miles. You can switch it to kilometers if you choose. I'm certain there's a method to do that. Now, if I wanted to explore a little bit more around it, I can update this to 20. And you can see the area surrounding it expands. And if I want to choose a different zip code, give it a second. And you see the zip code goes over here. So this is a way to, this is all due to the magic of Streamlit. So we already know the mapping aspect of this, but how does Streamlit work with these maps to create this dynamic movement? Well, as you can see, like first we read in our data sets. So this is the state data set. And we want to choose, this ST select box is, excuse me, we have the state that we can select right here. And this is essentially a message telling you what to do with your widget. And this is essentially all of the options we want to give to our select box. So this ST select box right here is allowing the user to select a certain state from our previous selection. So that's essentially what this is right here. And you can choose any state you want from here, as long as it's in the data set, which all 50 states are in the data set plus some territories. But that's essentially how you get the dynamic state. Like that's how the map changes to fit each state, or the map changes to display a certain state. So then we get the zip code file from that state using the US library that we used before. We read in the GeoPandas file, and then we want to get our and then once we read in the GeoPandas file, we get a list of all the zip codes within that state. So then we do the same thing, but with the zip codes. So this is the same situation. We have our list of zip codes right here that we want our user to select from, and we use the select box widget. We bring it up here, and we can select any zip code we want to, and it will automatically send that zip code to the program to be pre-processed. So then we get the zip latitude and longitudes. We create our points. We get the convex hull, and once we get that convex hull, we then turn it into a polygon, and we plot the polygon, and we can also get the main zip code latitude and longitude and plot that as a singular point too. And we can see the point DF right here. We turn it into both of them to a geo data frame with the proper coordinate mapping system. And then we create our plots down here, and the STPyplot fig will display it. So, sorry, I went through that really quickly. There also should be, sorry about that. And I glossed over this, I'm sorry. The distance is essentially on a widget, which we call the slider. So a slider is essentially how you create something like this, where you can select a certain distance based on a numeric variable. So with the slider widget, you can choose you can choose the kind of scale that you want to select on your widget. You can choose the max. Well, the max I selected is 50. The min I selected is 0. And then you can choose the intervals you want to travel to that max. So this is essentially how you can control that. So basically, this will be, this will be right. The max will be right here. The min will be right here. And then the intervals will be all the way here. So yeah. That's pretty much the dashboard on Streamlit. I recommend diving into it a little bit more I recommend diving into it a little bit more if you want to get a better idea of how all of this stuff works. It's a really fun library to use. It's very flexible. It's dynamic, and you can incorporate HTML into it pretty easily. So I recommend looking into Streamlit a little bit more if you wanna if you want to have a better if you want to practice with this a little bit more, if you want to add dashboards to your projects, because it's a very quick and easy way to do such a thing. By the way, I don't this was meant to be intervals, but for some reason I don't I made a mistake. This isn't intervals. This is something else, but I thought it was intervals when I did it. Sorry about that. Because clearly, like, you can select ones that are not between that. So sorry about the brief misinformation. But I believe we're. Let me ask if there are any additional questions about the dashboard incorporation.
I think we're good so far. So one of the things is at different points in time, like the code snippet that you're sharing was not
Mhm.
very readable. So one of the things that we can do is if you can share in any format, the code, like the notebook, the code, and the presentation
Mhm.
with me, so I can add that to a Google Drive and add that to the description of the YouTube video for this
Mhm.
particular conference. That'll be great.
Yep,
Because I feel like at
absolutely.
some point in time, it could also be because of the lag that the code is not very readable. So yeah, you
Mhm.
can clean it up, maybe put it on GitHub and just share the link with me, whatever works best with you.
Yeah, so sorry about that. I'll definitely do that. It's
Mhm,
well commented, so it's very easy to walk through, but I can completely understand.
mhm.
It's very hard it's probably very hard to read it on the fly.
Yeah,
Yeah.
that's probably it. So, what we can do is once you can just clean everything up, put it on GitHub, and you can add Jupyter notebooks as well on GitHub. And
Mhm.
once you can share the link with me, I'll put that in the description of this particular conference on YouTube, and that would be helpful.
Yep.
Awesome.
Now, so in conclusion, mapping's a very useful skill that I would recommend using for a lot of your projects. It's very simple. It's very powerful, and it's very flexible. And it's very easy to add to incorporate them into dashboards if you want to make them a little bit more dynamic. I had an addition. I also, if you want to take your mapping to the next level, a good strategy is to use Folium. Folium is one of my favorite methods of interactive mapping, and you can create some really fancy things from it. Let me show you the sample map. Oops, sorry. Hey, sorry, I'm just going to click on this. So I'm not going to go into how I made this, but you can add tooltips, and it's very easy to add it's very easy to add a lot of your previous plotting methods like Bronca maps. You can add specialized pins in it, along with tooltips for those, and you can add really cool backgrounds. So yeah, I'm also going to post in the folium mapping, but I don't have. This was more like bonus material that I created. If you're interested in learning more about it, I created a very concise folium script. If you want to look more into it, where I aggregated a lot of this information. So I recommend checking it out if you're interested in learning more. Thank you so much for attending. Y- um, there are a couple minutes for questions if we have any. You said we didn't, right?
Yeah, I think we don't have any questions so far.
Yeah.
And one of the yeah, I think that'll be awesome. Alex, once you share that with me, so I can add it and people can refer to this later on.
Yep.
And I have shared Alexander's um, link, like his LinkedIn information, in the description of the comments.
Mhm.
So if you want to connect with him, you can go ahead and connect with him on LinkedIn.
Yep.
Awesome.
Thank you all for listening. I hope I certainly hope you all got some valuable skills or information from this lecture, or learned something about Matplotlib you haven't previously. It's So yeah, thanks for having me, Ashwari. I really
This was
appreciate it.
awesome, Alex. I did definitely learn a lot because I haven't used geographical data or like map plotting so much.
Mhm.
So this was really really helpful. And yeah, thank you so much for being with us and going through this entire session so patiently, walking us through your code, etc. So thanks a lot for that.
Yep, thank you. I really
Awesome.
appreciate it.
Have a good one, everyone.
Yep, you too.
So we'll be continuing with tomorrow's session at 8 a.m. PT, and I hope like you guys enjoyed today's session. So I'll see you guys tomorrow at 8 o'clock in the morning PT. That would be around 9:30 p.m. Indian time, and that would be 4 p.m. GMT. So don't forget to tune in tomorrow as well. As I mentioned earlier, it's a 4 day long conference. Each day has two sessions. So tomorrow and day after, we're going to be having two sessions each, and similar to what we had today and yesterday, we will be having two more trivia questions in the days coming ahead. Each of the conference sessions are recorded and they'll be available for you to view on YouTube. And soon after we have wrapped up the conference, I will be adding more information in the description so you can access the content speakers have provided and you can connect with them on LinkedIn. So if you have any further information, if you're viewing this recording later on, feel free to connect with the speaker, and they'll be happy to answer your questions. Thank you so much, everyone, and I'll see you tomorrow.